Hello, AB students. This is AP review number 2 with Mr. Rickman. I hope you're doing well. So I hope this paper is available for you to print and you can work on this paper, but if you do not have a printer, then feel free to just write what I've got on notebook paper or clear white paper, typing paper as we used to call it. All right, so here's the idea of the day. Today we're going to review units 3 and 4, which is heavy and derivatives. This will be great. In each case, we're going to look at the big ideas, at least that the College Board feels are the big ideas. We'll look at some most missed or tough questions for a warm-up that are small, and then we'll do some free response practice. Now, I'm going to do this a little different than yesterday. It's going to be more like we would do in class. So I'll say, here, you give it a try, and you give it a try. And then if you get the same answer as I get, then you don't have to hear me blah, 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 which is better in class because normally in class you do. Instead, you can just, if you have the right answer, fast forward to the next part of the question or next question and work that part. If you miss a part, then I don't suggest, I demand you get out a red pen and make corrections to anything you missed, all right? So if you're really good at calculus, this won't take as long. If you make lots of mistakes, then you'll be trying it once on your own and then making corrections in red with me, and it'll take a little longer. So here we go. First, jot down a few quick notes of the topics. Number 3, our unit 3 yesterday. Unit 2 is very basics of the derivative, the definition of the derivative, and basic rules, the power rule, product rule, quotient rule. Today we're talking a little bigger ideas, harder ideas. Chain rule, remember, you use when you are taking a function within a function. Okay, kind of like anti-U sub if you like. Implicit differentiation, remember, usually you take the derivative with respect to x of both sides. That's the proper notation. Anytime you get a y, you'll take the derivative of the inside, so dy dx will pop up. And remember that if you get a implicit derivative, 0 on the top is a horizontal tangent, 0 in the bottom is a vertical tangent. Differentiating inverse functions. Inverse functions, remember the idea is the derivative of the inverse is 1 over the normal derivative at the inverse point. These are some things we might put on reference sheets so you can easily find them when you're taking the test. You want some structured reference sheets so that it's easy to locate stuff if you get stuck and you're not looking through your notes and all the time's ticking, all right? Differentiating inverse trig functions. We learned that from the very basics of doing implicit differentiation on reverse kind of thing. But we will definitely want to know that the derivative of arcsine is 1 over 1 minus u squared, and the derivative of arctangent is 1 over 1 plus u squared. And then what else we got? Choosing what to take a derivative and how to take second, third, and so on derivatives. All right, so let's go here. And I went the wrong way. Let's start here. Would you pause for a second and do this problem and tell me what you think here? Originally it was multiple choice, but I stripped them off. Okay, so the answer is B. If you agree with B, then feel free to move on. I don't suppose you need work on this one. Just have a big old B on your paper and move on. But if you do not have B, then let's talk about it, shall we? So the idea here is the graph shows the first derivative. Read carefully. It's not f, it's the first derivative. At which of the 4 values, a, b, c, or d, is f double least? So I would, all right, start the dialogue with myself. F double is the slope of f prime. So I want to know, when is slope of f prime least? Well, that's about 0. That's a pretty big negative. This is also a negative, but not as big. And that's a positive. So it seems like that's going to be the least, a big negative number. So I choose B. All right? All right. Try this problem. And when you're done, unpause the video and we'll check your answer. Okay, so your answer should be 1 and 3. Chain rules. So if you got 1 and 3, then feel free to move on to the next question. Chain rule is required when you have a function within a function. This has a function within a function. This is a product rule, so it is not a function within a function. And this is a function within a function. So that is chain. It is 1 and 3. All right? All right, this one is a humdinger. All right, you better be on your game. This will make you think. So try this one, and then we'll check answers in a minute. Okay, so my answer is 15 fourths. Did you get 15 fourths? If you did, then give yourself a pat on the back and go to the next question. If you didn't, then get out the red pen and let's make corrections. All right, so we have this problem. F of x, g of y equals 24 plus x plus y is some kind of relationship. It's implicit. Think of over here like if it was x squared cosine of y kind of thing. It's a function of x and y on the left side, all right? So if you want dy dx, then we need to take the derivative with respect to x of both sides. Just so we're clear, I'm not multiplying by d over dx. That's ridiculous. That's an operation I'm doing to both sides. All right? So here we go. The derivative of the left. Well, we got a product, so I have to use the product rule. So let's start that. First stays the same, f of x. Now when I take the derivative of g of y, that's, whether you know it or not, a function within a function. So you're going to take the derivative of the outside, which is g prime of y, but then multiply by the derivative of the inside. So that's dy dx. Plus second stays the same, g of y, times the derivative of the first with respect to x. Well, that's f prime of x. The derivative of the left is easier. It's 0 plus 1 plus, and the derivative of y with respect to x is dy dx. Cool? Now it's up to you whether you put values in and then solve for dy dx or solve for dy dx first. I'm just going to use values here. So f of x, this is the point I'm using it. All right, so x is 1. F of 1 then is 4. G prime of y is 3. So g prime at 3 is 1. Dy dx is that which I'm looking for, plus g of y. Again, y is 3, so g at that y is 7. F prime of x, x is 1. F prime at that 1 is negative 2. And then 1 plus dy dx. So if I simplify, I get 4 dy dx minus 14 equals 1 plus dy dx. If I get the dy dx is over, oops, I have a mistake, don't I? Sorry, if I get the dy dx is over, then I get 3 dy dx, doggone it, equals 15. So maybe it's not 15 fourths. I apologize if I just wasted your time watching this video. I get the dy dx is 5. Dy dx is 5. Why did I screw that up? I'm not sure where I went wrong in my work. At any rate, I made a mistake somewhere. Okay, so do we agree? I thought 1 is 4. I'm not sure what I did wrong there. All right, at any rate, dy dx is 5. I apologize. All righty, then here we go. Now, I want you to get some practice on implicit differentiation. So you're going to do this problem all the way through, which is an AP free response. I added a part E just for kicks, and then we'll talk about it in a minute. Go. Okay, so let's see how you did. The first one, they gave you the answer. The work is really just showing. Now, I will be careful. They're giving you the answer because they want you to be in for the rest of the problem. But that said, because they're giving you the answer, to get the points there, you have to be very clear that you can show clearly without skipping steps where the answer is coming from. So make sure you show good work there, and if you feel like you did, then feel free to move on. Otherwise, watch the video when I come back to that. For B, your answer is y minus 2 equals negative 2/3 x minus 1. For C, I have 8/27. D is negative 9/2. And E is, the answer is no with justification. All right, so if you missed any of these pieces, then let's talk about what they should look like. Just to be clear on A then, here I go with A. What good work looks like would be to take the derivative with respect to x of both sides. The derivative on the left is a product rule. First stays the same. Derivative of the second plus second stays the same. Derivative of the first. Derivative of y squared is the derivative of the outside, 2y, times the derivative of the inside, dy dx. And the derivative of 8 is 0. Alrighty then. Let's get the dy dx's together and move the 2y over. So I'm going to have something like, actually, yeah, I can divide each term by 2 to get rid of a 2. What do you think? You don't have to do it in this order. But x dy dx plus y equals y plus dy dx equals 0. All right, now let's get our dy dx's together. Dy dx factored out of x plus y, and I get a negative y when I move that over. And last but not least, dy dx is negative y over x plus y. And I feel like that work is clear to anybody who knows a little bit of calculus. All right, let's go to B. It's important to understand that sometimes they will say, instead of a tangent line, they will say local linearization. Just so you're clear with the verbiage there. All right, so anytime you do a tangent line, you need a point. They give it to you. You need a slope. We use the derivative at 1, 2, and then we write point slope. So if this is the derivative, then at 1, 2, I'm looking at negative 2 over 1 plus 2, or negative 2/3. Plugging in the point in the slope, then that's where my answer is coming from. All right. Let's look at C, the second derivative. So let's start by the first derivative. We have the first derivative equals, leave a space, negative y over x plus y. And what I'm going to do is take the derivative with respect to x of both sides. Therefore, the derivative of the derivative on the left, in good Leibniz notation, is that. The derivative on the right with respect to x is quotient rule, so low. D high, the derivative of negative y is negative dy dx. Minus, not plus, minus high, negative y, I guess that will be plus. D low is derivative of x, which is 1, derivative of y, which is dy dx, over the square of what's below. All right, and that then, if we substitute in the derivatives, I say in place of dy dx, or negative dy dx, would be y over x plus y. That's nice. Plus y times 1 And plus dy dx is minus y over x plus y over the square of what's below. All right. At that point, we could keep cleaning up, or we could start putting stuff in. 1, 2. So the second derivative at 1, 2 is, this is just a y, so it's 2. There's a 2, 1 minus, and y over x plus y is 2 over 3, and 1 plus 2 squared. Now on the AP test, if you left it like that, you would get full credit, and I suppose it would be wise to do so, especially if you're running out of time, and not interject the possibility of making mistakes. But me, I'm old school, and I say when you do math, you get an answer. So I'm going to go on, and I'd get something like 2 plus 2 times a third, so 2/3 over 9. If I multiply top and bottom by 3 to clear the fractions, then I get something like 6 plus 2 over 27, and that's where my answers come from. Okay, D. This one is rough. You might have missed this one because this one was tough. All right, so let's go here. I got started fine. The derivative of the inverse is 1 over the normal derivative at the inverse point. And this one is harder because the derivative depends on x and y. So let's talk about what point we're going to go with. Now, remember, this is x equals 1 in the inverse. Well, that would mean the same as you find a point where y equals 1 in the original. That's this guy. And so we're going to use the point 7/2, 1 in the derivative. If I use 7/2, 1 in the derivative, then I get -1 over x plus y, which is 9/2, and that is negative. That's 1 over -2/9, which is -9/2. That is a mess. All right. Last but not least, is there a point on the curve where the graph has a vertical tangent? Let's talk to ourselves here. Graph has a vertical tangent if dy dx is non-zero on the top and 0 on the bottom. So there's rise but no run. That would be then the case that only if x plus y equals 0. So maybe x equals -y, or the opposite of y. Now, that's great, and you might say, okay, there you go, if x is the opposite of y, but it's got to be on the curve. Now, if I put this on the curve, then I'm going to put -y in for every x in the curve equation. So I would get 2 times -y times y plus y squared has to equal 8. Is it possible for x to be the opposite of y and also be on the curve? Well, I get -2y squared plus y squared equals 8. That's -y squared equals 8. That's bad. That means y squared has to be negative, so there is no real answer. Those are imaginary solutions. So from that, we can conclude that the condition you'd need to have a vertical tangent isn't actually a point on the curve. All right. Let's go to Unit 4. Unit 4 is applying the derivative. Now, remember, the derivative is a rate of change at an instant. When you go to interpret the meaning of this, it might help, instead of w prime at t, to think of this as dw dt, change in w, or whatever it might be, over change in time. Okay, it's a rate or a ratio of time. So it sometimes helps to take the prime notation and make it Leibniz notation so you remember it's a ratio of change. Let's talk about motion and all the big ideas. I mean, we've done this a lot, but velocity is the derivative of position, whether or y prime or h prime or whatever it might be. Acceleration is the change in velocity over time. So it's either dv dt, change in velocity over time, or v prime. It's also the second derivative of position. All right. Speed. Speed is the absolute value of velocity or the change in position over time without sign in it, kind of thing. It's one of those. And remember, speed is increasing if velocity and acceleration have the same sign. All right. You could do rates of change in a lot of things. How is the height changing with time, or the rate at which people enter? There's so many, gosh, so many calculuses everywhere. Related rates, especially when you're doing free response. Remember, you identify the givens, the question of what you want and when now, and you get an equation. Hopefully you get it in two variables, and then usually you differentiate with respect to time. Here's that idea I was talking about on the previous slide, approximating values using local linearity. Local linearity is the same as a tangent line. Okay, and then L'Hopital's rule. The only cases you'll see on the AP test are either 0 over 0 or infinity over infinity, plus or minus. And make sure you show quality work. Show individual limits and then take the derivative, all right? Okay, so let's do a warm-up. Would you try this one? And the geometry of this is gross. All right, so try this. It took me about 5 minutes. And then check your answer in a minute. Okay, let's see how you did. I got an answer of 1/6 feet per minute. If you got 1/6, then you probably killed it, and move on to the next question. If you didn't, then get out your red pen and let's make some corrections, shall we? All right, so you are given that the volume is coming in at 2 cubic feet per minute, and you want change in height at time equal 2 minutes. All right. So first I get an equation. Volume is area of the base times the height. Area of the base, you could go a couple different ways. But I want the height in there. Base times base divided by 2. The hypotenuse is 2 feet. Okay, so we need to get some kind of area of the base calculation here. We're going to talk about that, and I'm not sure if I like my answer of 1/6 anymore. We'll come back to that, and yeah, we'll see. Excuse me. Okay, so I think you'll agree then that if I put the right angle there, then the area of the base, forget these guys. The base here is 2, the height is what it is, and so the area of the base is 2 by h over 2. Yeah, my answer is definitely wrong. Times the trough length of 9. So the volume is 9h. 3 dimensions, yes. Okay, so my answer is wrong. I'm sorry. So here we go then. dv dt is 9 dh dt, and yeah, that's dumb. Yeah, darn it, now I remember why I screwed up. Sorry. Hey, can we go back here? And so the problem is on the area of the base, to say this is 2 by h divided by 2, that's great, but that's the area of the trough. I want to know the water in the trough, you dummy. And so let's look at this a totally different way here. When I talk the area of this trough, what will it be like? So let's go back to this. And I say again that the area is base height divided by 2, but it has to be where the right angle is. So I suppose that's like base squared divided by 2. But again, the whole question is, how's the height changing? So we need to relate the height to the base and make it all h, right? So let's go here. Let's look at a little bigger case here. This is a right triangle, and these are the same. So that makes these the same. And so if I want to know what is the height, then doesn't that make that like a 45, 45, 90 relationship here? So, oops. So like 1, 1 root 2, so will be the relationship between our general B and H. So H is to 1 as B is to root 2. So I could say that B could be replaced by root 2H. Cool. So if I take root 2H and throw it in for B, then I get something like just 9H squared. Now actually that makes sense a little bit, because if I wanted the area of this, couldn't I just take this triangle and lop it over here and it would be an H by H square? So that the area of that would be H squared is totally logical. Why didn't I see that before? All right, so here we go now. Differentiate with respect to time. dv dt is 18h dh dt. I have this. Cool, it's 2. I don't have this, and this is what I want. All right, now let's go there. It says at time equal 2 minutes. At time equal 2 minutes, the volume has changed because it started empty and then it came in at 2 cubic feet per minute. The volume is now 4 cubic feet. Now if the volume is 4 cubic feet and the volume is 9h squared, then that means the instant must be the square root of 4/9 or 2/3. So dh dt then is 2 equals 18 times 2/3 dh dt, and that's where you're getting a 2 divided by 12, and that's where 1/6 came from. That was right. All right, are we good? Phew, that was a humdinger. All right. Excuse me. Try this one and we'll compare answers in a minute. Okay, so here we go. You get a position function. You want to know where speed is increasing. I was thinking the best thing about taking the test in this fashion, you'll be at your home in your jammies. You can talk to yourself all you want. Unlike a test in a AP test in a big old gym. So that's nice because I solve a lot of problems by talking to myself. I would start by saying, hey, self, speed is increasing if velocity and acceleration have the same sign. So I need to determine some kind of signs of velocity and acceleration, so I'm going to go superchart. Velocity is the derivative of position, which, oh, by the way, sorry, the answer to this, and if you want to check your answer, the answer is going to be D. Sorry. If you got D and you killed it, feel free to move on. Sorry, you don't have to waste your time listening to my explanation if you understood what you were doing. If you didn't get D, let's talk about it. And I hope you're not just saying, I don't understand, I'm just going to listen to his video. Oh, yeah, that makes sense. Now I get it. No, that's not calculus. You're not going to do well, okay? If you just are totally relying on me every time, you're wasting your time. I'm not going to be there. You need to struggle on your own. Stop relying on me if you're waiting for me to do it. All right. So, back to this. I digress. The derivative is 2t squared minus 10t plus 8. As far as figuring out where this is positive or negative, I've divided out of 2, and I'm getting zeros at 4 and 1 is where it changes sign, right? I'll do signs in a second here. Acceleration is the second derivative, or the derivative of velocity, and that is 4t minus 10, and that's 0 at 5 halves. So as far as my intervals, I have 0 to 1, 1 to 5 halves, 5 halves to 4, and 4 to 5, based on the say they stopped it there. All right, velocity then is going to be positive, then negative, negative, and positive. Acceleration is negative before 5 halves and positive after. And so if I look for where speed is, velocity and acceleration have the same sign, there's one, they're both negative, and there's one, they're both positive. All right, so that's where D came from. All right, free response. Now, I didn't take all of free responses. I took bits and pieces that I found interesting or challenging. So would you try this one, which is a piece of a free response? They're giving you the graph of F, just to get you started. Graph of F and the graph of F prime, and I gave you one of the parts of the free response. Try it on your own, and we'll go over it, or check your answer in a minute. Okay, sorry about the delay. I lost my key to this. All right, pause for a second. Okay, sorry. Did I not pause this? All right. So anyway, the graph of, or the first limit should be 4, and the second is does not exist with good explanation why. If that's what you said and you don't feel like you rocked it, then go to the next question. Otherwise, stick by and let's make corrections with your red pen. All right, so this is, geez, a huge idea of calculus. If you don't look at that and know what to make of it, then you really have some lack of understanding of calculus. I understand it's scary, but you need to think your way through it. So anytime you see an expression like this, a difference quotient, it's change in f, which is change in y, over change in x. So it's slope between 2 points. And then this is the 2 points getting closer together. Think of it this way. -1 is one of the points you're looking at. X could be lots of points, and so it could be here, and we could look through the slope there. Or X could be here, and we could look through the slope there. Or X could be here, and we could say, what's the slope there? But as X gets closer and closer to -1, we start to approach the slope at -1. So this first limit is the derivative at -1. And so we don't have to estimate what the tangent slope is, which would be difficult. Instead, we can say, oh, here, this is giving us the derivative. This, by the way, is very logical if you think about it. This is a positive parabola, so its derivative being a positive line makes sense. This is a negative parabola, so its derivative being a negative sloping line makes sense. And this is a line, so its derivative being constant makes sense, yeah? Now, back to the idea here. If I say, all right, what's the derivative at -1? Well, here's the derivative graph. Here's -1. The derivative is 4. Now, I hope you didn't start opening thinking, oh, it's not differentiable at -1, so it does not exist for the first. No, that would be if you were looking at the derivative of this graph, and the derivative of this graph would be the second derivative. That's not the question, right? So don't think, oh, no go because of the sharp turn. That's not it, right? The answer is 4. The second one, this is the slope between 3 and some point. Well, that's going to matter if you let X be a point over here and draw the slope as you get closer, or if you let X be a point over here and draw the slope. But I think you'll agree that the slopes are totally different on either side. They approach different values, and so you're going to say the limit as X goes to 3 of this slope calculation or difference quotient does not exist because, and here's where we use good notation, the limit as X goes to 3 from the left approaches, well, what does the slope approach from the left? Well, the slope from the left is the derivative from the left. The derivative from the left is approaching -4. The slope from the right is the derivative from the right, and the derivative from the right of 3 is +3. And so the limit does not exist because the one-sided limits are -4 and 3, and -4 doesn't equal 3. So please don't just leave it at this and say, hey, the one-sided limits are -4 and 3. You make the connection that they're not the same. No, that's your job. You need to say, and those aren't the same, right? Okay, last but not least, try this for your response, and then we'll be done and done. All right, here we go. Let's see how you did. Oh, darn it, I gotta get my notes out again. Pause that. Okay, so let's check your work here. For A, if you have 3/4, then you can probably skip on to B. Now B is rough. Your estimate should have been 6.242, and then you have to explain why W at 2.5 must be greater than 6, and that's difficult. And then C, you should have had something like -π/10 - 4 for an answer. If you had, so here we go with part A. If you had 3/4 for part A, then feel free to fast forward to part B. If you didn't, then let's get out the red pen and make corrections. All right, so W prime at 7 is going to be the derivative of the branch that involves 7, so that's this one. So the derivative of 6 plus 1/8 of t minus 4 squared is equal to, at 7, is equal to 0 plus 2 comes down, t minus 4 drops to 1 at 7, and so that is 7 minus 4 is 3 fourths. All right, also it said, explain the meaning of w prime of 7 in the context of the problem. I don't like to interpret Newton notation. I like to interpret Leibniz notation because that tells me that it's change in W, which is the depth of the water, over change in time in hours. All right, so my explanation goes something like this. At time equals 7, what are the units on 7? Hours. The depth of the water is, if the derivative is positive, then it's changing in a positive way. So the depth of the water is increasing at a rate of 3/4 feet per hour. All right. B, like I said, B was difficult, so let's talk B, shall we? So let's start with the line tangent. The concavity thing, you might not know what to make out of that. We'll come back to that. Let's do the tangent line, all right? You might not know what this is about and how am I supposed to do this. Get some points, okay? What you can do is write a tangent line. So don't throw your hands up and say, I can't do it. Just try, do something, and you'll get some points. So the tangent line is the point is when time is 2, what is W? So let's get that actually. W at 2 is the top branch, so that's 32 fifths plus 2 fifths of cosine of pi over 2, and that's 32 fifths. All right, the slope is the derivative at 2. We'll take the derivative of that branch, which is 0, plus 2 fifths. The derivative of cosine is negative sine of pi t over 4 times the derivative of the inside, pi over 4. We need to evaluate that at 2. So that is, if I put the sine, the 2 fifths, and the pi over 4 together, I get negative pi over 10. And then sine of pi over 2 is 1. All right, so my tangent line is y minus 32 fifths equals negative pi over 10. It's not x in this problem, it's t, so t minus 2, all right? So there's this curve, and I wrote a tangent line equation to it at 2. All right, so W at 2 could be approximated with my line at 2. And if I put my 2 into my line, I would get 32 fifths minus pi over 10. 2.5 is what I'm estimating. Times 2.5 minus 2. So that's 32 fifths minus pi over 10 times a half. And at that point I said calculator time, and I got an estimate of 6.242 when I put that into my calculator. You with me? All right, great. I used the tangent line. Now show that W at 2.5 must be more than 6. Now here's where a picture helps. I have a curve that's concave up, according to what they say, and I did a tangent line at 2. Well, if I go to 2.5, won't the curve have to be more than whatever my tangent line says? Well, my tangent line is 6.242, so the curve has to be even greater than 6.242, and therefore, obviously greater than 6. So now let's talk about how to say it. I will say something like this. The curve is concave up, so the tangent line underestimates. Now, as much as it would be tempting to say, yep, call it good, therefore, W at 2.5 is greater than my tangent line, 6.242. And that's greater than 6. So I can conclude that W at 2.5 must be greater than 6. Right? And last but not least, this bad boy. The minute I see this, I think, oh, this is going to be L'Hopital, and in this case, it was right. So make sure you show the work properly. Show each separate limit. If I say, what about W at 2 minus T squared minus 12 fifths, W at 2 we said was 32 fifths from our tangent line. T squared is 2 squared, so that's 4 minus 12 fifths. I put those two together, that's 20 fifths minus 4, that is indeed 0. The limit in the bottom is obviously 0. So by L'Hopital, the limit is equivalent to the limit of, take the derivative, W prime at t minus 2t minus 0 over 1. Now W prime at t, as t goes to 2, is W prime at 2. W prime at 2 we found in the previous part, that's negative pi over 10. As t goes to 2, negative 2t goes to negative 4, and that's where my answer came from. I believe that is all. That is it. So if you have finished and corrected and graded it, send it in to AP Classroom. And if you're doing this Friday, good job. Have a great weekend. If you're doing this Tuesday night at 7 o'clock, shame on you. You really waited to the last minute. Shame, shame, shame. But either way, have a great day.